So in this video, what we're going to look at is the difference between distance and displacement, and hopefully be able to calculate the difference between these two things. First off, what is the difference? Well, I'm sure you've all talked about distance before. Distance is just the physical length between 2 points. All right, how far has it traveled? So if you go from here to Chicago, your car's odometer is going to register that you've traveled, 150 miles or whatever. It's something we call a scalar quantity, and it's a mathematical term that we'll get to here a little bit later in defining. But for now, go ahead and jot that down. We'll come back to what scalar means later. Displacement, on the other hand, is just the difference between the final position and the initial position. Now, it's a little bit different from distance sometimes, and we'll show how it's different. But for now, what you really want to pay attention to is that it just doesn't matter what happens in between your starting position and your final position. Okay? It's just the difference between where you start and where you end. And instead of being a scalar quantity, it's something we call a vector quantity. Now, with this idea of the final position and initial position difference, all right, we can literally write out an equation from that definition. Displacement, all right, and the initial position and the final position are the three terms we're looking at. Final position is right here. We've got the difference, so that's going to be subtraction, and your initial position is xi. We've looked at that before. So then this guy, displacement, must be right here. All right. Now, x always means position, whether that be the final position, the initial position. So what does this triangle do? Well, that triangle stands for change in the position. And a change in position can be described also as displacement. So we will see this symbol pop up different places, whether it be the change in velocity, the change in time. Okay, so that's what that triangle means. Very important to remember that. But let's look at the difference between this scalar and this vector quantity. Now, if you've ever watched Despicable Me, all right, you've got this guy over here. All right. This guy's name is Vector. Okay. And you can watch the whole clip later on. But what you should remember, or if you go through and watch it, is that Vector is named after a mathematical quantity. All right. Where he is doing crime with both magnitude and direction. All right. Scalar quantities, which was a distance, just as a magnitude, like how big is it, but no direction indicated. Vector quantities will have both direction and magnitude. So, for example, you may travel 50 miles. Well, was that 50 miles on a track, in a circle? Was that 50 miles in a straight line, in some kind of zigzag course? All right, it doesn't say. With a vector quantity, I traveled 50 miles to the northeast or west or whatever. Or it could just be as simple as I traveled in the positive direction or the negative direction for 50 miles. So the vector quantities have a direction attached to it. So let's take a look here. We're going to go through 3 or 4 examples here on this one. All right, if we want to calculate the distance and the displacement, well, first off, I'm going to mark off a few things, like I'm going to put this as the starting position. Let's find out where it goes. Okay, and it travels way over here. So that's its final position. First off is the distance, the physical length that it's traveled. Well, it went from 0 to 7, so it's 7 meters. Okay, simple enough. What about displacement? Well, displacement, again, we need to know the initial position and the final position, which we do. And we take the difference. So in this case, when plugging it into that equation, it's the same thing, 7 meters. Let's try this one. So we've got an initial position over here. And it travels to here. So let's work it out. Distance, well, went from 7 to 3. So it's 4 meter difference. Simple. Now with the displacement, we look at the starting position and final position. And initially people will say, oh, that's same thing, 4 meters. Not quite. All right. Because if you look at the equation, it's the final minus the initial. So instead of 7 minus 3, it's 3 minus 7. So it gives you a -4. Notice how the negative came from the fact that it's moving to the left, which is towards the negative end of the number line, where the first one was moving to the right, which was the positive end of the number line. So again, that scalar quantity didn't have a positive or negative to it. But the vector quantity does. It implies a direction. Let's go again. Okay. We got the car starting here. Oops, that's supposed to be the initial. And let's see what happens here. That got a little bit more complicated. So it went all the way out, I think about the 8. Yes. And then came all the way to about right there. Okay. So distance traveled. Well, it traveled 8 over here, and then 13 over here, which gives us a total of 21. So the odometer would have gone up 21 meters if we had an odometer on this car. What about displacement? Well, we've got an initial position of 0 meters. We have a final position of -5. So since, again, displacement is final minus initial, -5 minus 0, well, there you go. Displacement here is -5 meters. Because it doesn't matter what happens in between, we're just considering the start and the finish. And there you go. That's how you do displacement and distance.